What's that?
You're wired for sound.
Yes. Can everybody hear me okay?
Oh, I can see that.
That would help with all this. We'll turn it off. Hi, Carol.
Maybe just put the battery in the.
I think it's fine.
Backwards.
What now? I think it's fine.
For the sound? I think the sound sounds fine to me. You want to sit close to me? I know you have to be. I think that's.
He certainly is tricky, isn't he? He is. We're just a problem.
Right?
Right.
Testing.
Bob, is your mic off?
Yes, it's on.
No, off. Turn it off for just a second.
Okay.
Good evening. Glad each and every one of you could come here tonight. We just finished up a wonderful meal, so those of you that might have missed it, Sybil and Ellen, I just want to let you know it was great. So we're looking forward to hearing Dr. Herman speak tonight. Dr. Herman and myself, and where's Drew? Where's Dr. DeCat? And Dr. DeCat, we practice in the same office. So when we're in there seeing patients, we're very studious and, you know, we're dedicated and everything. But then when we get back to the main room, Noreen tells us that we act like a bunch of 10-year-olds. So we've known each other for a long time. As a matter of fact, Drew and I have known Bob so long that Bob used to have an afro. I know you don't believe that, but Drew, is that true?
That is true.
That is true.
He looked like Art Garfunkel.
That's right.
Yeah,
So,
that is true.
but anyways, he's here tonight to talk about intelligent design. And when we were in the office, every time I'd come into the office, he would say something like, hey, I read this, or, you know, I saw this on the internet. This is absolutely amazing. As a matter of fact, I stopped coming into his office because he kept telling me stuff. And finally I said, Bob, you got such a passion for this. You know it, you know. And Bob is the only guy that I know, and he claims this to be true. I'm not sure it is. Drew and I kind of have our doubts. He says he's been through the internet 3 times. And so if there's anybody here that is knowledgeable to talk about intelligent design, it is Dr. Bob Herman. So let's welcome him with a round of applause. Bob, it's all yours.
All right. Thank you. Mickey, I want to thank you for inviting me to come talk about CNAs, Certified Nursing Assistants. CNAs are very important in the medical community. What?
We're here to talk about DNA, not CNA.
Really?
Yes. Did you change
DNA?
the slide program? Yes.
Not CNAs.
No, DNA.
Really? We're going to take a short break. Okay, fortunately I have slides on that too. Okay. Did I miss something? What did I miss? Okay, Danny. Okay, Plato, Aristotle, Cicero, Kepler, Faraday, Boyle, Isaac Newton, Albert Einstein, many other scientists believed in design in nature. Bertrand Russell, who was a philosopher, a mathematician, an atheist, he lived in the 19th century, the 20th century. He died about 1970. And Bertrand Russell was asked by a reporter toward the end of his life what he would do if when he died, he woke up and he saw God there talking to him. He said, what would you say to him? And Bertrand Russell said, I will reproach him for not giving us enough evidence. Okay? So something changed between Isaac Newton and Bertrand Russell, and that something was Charles Darwin. Charles Darwin, he taught scientists to look at science differently. And he taught them that if they're going to examine science, that they need to look at the cause and effect of nature, and that they need to examine it from only a natural point of view. So that is changing now in science. That's in kind of an old way. There's a big revolution going on in biology, in mathematics, and in chemistry. It's a quiet revolution, but if you get online and you look, they're having some mild wars about this. It's really, and I didn't know where to bring this up, but it's kind of early in the talk to bring this up because I really haven't presented much of a case yet. But, I got thinking about it, this is probably the best time to bring this up because that's what we're talking about right now is this war, mild war going on in biology. This is an online petition, and it's called A Scientific Dissent from Darwinism. And there are over 1,000 academics that have signed this. And what they're signing is, we are skeptical of claims for the ability of random mutation and natural selection to account for the complexity of life. Careful examination of the evidence for Darwin theory should be encouraged. And there's 1,000 signatures on here. These are all professors. They're, paging through here. We've got Ohio State University, Ball State, Northwestern College, University of Kentucky. We've got Harvard, UCLA. These are professors that are saying that we have enough evidence now that Darwinism and random explanation of biology does not fit. So that's what we're going to talk about tonight. Danny? Okay, so there is a quiet revolution going on, especially in the sciences of DNA. And tonight we're going to explore new findings in DNA and information theory and how to make proteins. That's the biggest discrepancy, is making proteins in your body, the process on how that happens. This relates to origin of life questions. We're going to talk about evolution versus intelligent design. This is important because it shows that life is not a random string of events, but is directed towards a purpose. We are going to give detailed scientific evidence pointing to intelligent design as the only reasonable alternative to the question of where the massive amounts of information in nature come from. And that massive amount of information is used for the production of proteins. We can make a positive case for intelligent causation based on the type of information in nature, and that's called complex specified information. And I'm going to explain what that is. Since Darwin, a mechanistic, materialistic view of the world has dominated. With the new science of information, this is changing. Next. So, intelligent design, we need to kind of define our terms here. So the next few minutes, we're just going to kind of define what we're talking about. Intelligent design is a scientific theory that holds that the emergence of some features of the universe and living things are best explained by an intelligent cause rather than a random, undirected process such as Darwinism. ID theorists argue that design can be inferred by studying the informational properties of natural objects to determine if they bear the type of information that in our common experience arises from an intelligent cause. Next. Okay, so ID, intelligent design, is not creationism. I want to present it in an accurate method here. It's not creationism. It is not a religious theory, but it has very profound religious overtones and implications. It is a scientific theory that uses a form of scientific reasoning that was developed by Charles Lyell, who was a great, he's considered one of the fathers of biology, and he lived at the same time as Charles Darwin. And they were contemporaries, they knew each other. And so Charles Lyell developed this form of scientific reasoning. And his theory says that if you want to understand the events in the remote past, you must look at the cause and effect structure of the world. And this method is called the inference to the best explanation, or the method of multiple competing hypotheses. Okay? I know this gets a little deep, but just it's a method of scientific reasoning. That's what they're talking about, because this is a science where they're trying to show through science that a God or an intelligent, that's the best explanation. Okay, so this method goes like this. The method of multiple competing hypotheses. Suppose you're trying to figure out something that happened in the past. You would develop multiple theories or multiple hypotheses on what exactly happened. And so then you would try to decide what is the best one, which hypothesis is the best one. So how do you decide that? How do you decide which one is the best one? The best hypothesis is the one that provides a true cause, or a cause that is known from our uniform and repeated experience to cause the effect in question. We do this all the time. You didn't know that you were using a form of scientific reasoning. So let's give a couple of examples. If you went out to Arizona and you saw that big crater out there, and you're trying to figure out how did that happen? Where did this crater come from? You might say, well, maybe it's wind and erosion. I mean, that would be a theory. Maybe it came from an earthquake. Maybe a meteor came, or an asteroid came down and hit it, and so you did all your experiments, and then you would try to come up with it, which is the correct one. The best one would be the one that is the cause that is known from our uniform and repeated experience to cause the effect in question. So you might study those asteroid or meteorite impacts on the moon, and you try to put all this together. Another example would be the Rosetta Stone. Suppose you were an archaeologist, and you're digging and you find the Rosetta Stone. And for those who don't know, the Rosetta Stone was a piece of pottery that had 3 different languages on it, inscriptions, and I don't remember how old it was, but it's ancient. And so they would, if you dug that up, would you think that you'd come up with different hypotheses, but would you think that came from wind and erosion? After going through, you'd say, no, the marks on there are similar to this marks from an alphabet, and you check the chisel marks, that it was made from an instrument. You put all that together, and it's the cause that is best known from our uniform and repeated experience to cause the effect in question. Some of these important parts, random in design, this from our uniform and repeated experience, I put up here because we're going to kind of be going back to those again and again. So if you're thinking, what was that he said? If it's an important point, it's probably up on this board over here. Okay, the only known cause of complex specified information is intelligence. Another example would be a forensic scientist. If they can go and investigate a crime, they put together multiple hypotheses, and then they try to decide which one's the best one from our repeated experience. Next. Okay, so we're going to show that new functional protein configurations that Darwin says must be discovered by chance cannot happen through a random process. And that new proteins, these new functional protein configurations, have a special type of information in them called complex specified information that in other contexts, like forensic science, are shown to have an intelligent cause. Therefore, it's reasonable to conclude this biological information and other information-rich features in nature are the result of intelligent design or an intelligent cause. Next. Okay, now we kind of talked a little bit about defining our terms. We need to define what information is. Information is what is conveyed or represented by a particular arrangement or a sequence of things. Information is the reduction of uncertainty. And before the computer age, nobody thought anything about information. It's a new science. It blossomed with the computer age. There are different types of information. Claude Shannon, is considered the father of computer science. He's the one that took this and developed it into a science. And so they call it Shannon information. That's one of the types of information is Shannon information. Then there is semantic information. And we do this all the time. Every time you fax something or you send a text message, you're working on a computer, you're using semantic information. Semantic information is meaning conveyed to and perceived by a conscious agent. Then there's the type of information, and these overlap a little bit, that we're interested in called complex or specified information, sometimes called functional information, and we abbreviated CSI. Okay, so I've got some letters up here. Next, Danny? One more. I'm sorry, I skipped a slide there. Or it wasn't up there. Can you go back one? This, one forward. Okay, this is the one that we missed. This is Shannon information, semantic, and complex or specified. This is the one that we're interested in. Okay, then forward one, Danny. Okay, so I've got some random letters up here. And there's 25 letters up there. This is Shannon information here. And because every time we put one more letter up there, we're reducing the uncertainty of what fills that slot. If we have 25 letters and we put one up there, now we've reduced the uncertainty. That's the mathematics scientific term for that. Okay, so then what I did is I rearranged those letters. And so those top letters are rearranged into 7 years ago. So it's the same amount of Shannon information, but now it's a little bit more because now we have some functional information up there. That sentence is there and can show a message, and it can convey a greater amount of information because it means something. It has a function. 7 years ago is it's a time in the past that everybody here could figure out if anybody knew what score was. Yeah. Okay, so each one of those has Shannon information. The probability reduction is the same. Okay, this is where it gets a little tricky. If you have the top line and the bottom line, and you had your 25 letters and you pulled them out, what are the probability of getting the first one? And what's the